My name is Lauren Herway, and I'm working with Stephanie Shepard, and we are working with the World Wildlife Fund to look at the impacts of planned dam construction on protected areas around the world. Next slide. Might want to press the share too, if you can.
Pardon?
Can you press the share button up there too?
I did.
Oh no!
Did it go? Is it not there?
Yeah,
It's
maybe
not.
hit the present button. So
Oh.
we're still seeing the full layout with the multiple slides on the left.
Huh. Well, I did press present.
Okay.
Let's see. Okay, I'm gonna do this again.
Okay.
Well, you know, my drive stopped again, or my stuff stopped again, but then it started back up, so maybe it freaked out.
Let's see. I don't see anything yet. Let's see.
The days of Zoom.
Okay,
Are you
I am
ready?
back. So present. Does it work?
You're not sharing your screen anymore,
Okay.
actually.
This is why last week I went to campus. This week I couldn't swing that.
No worries.
Okay. Can you
Yes.
see it?
Awesome.
Sorry.
Can you go back one slide, I think? Just back one.
Yeah.
I always get frazzled with that, yeah.
There we go. Okay.
All right. All right. So dams are crucial for things like electricity, flood control, agriculture, and water access, but they also can hurt ecosystems by flooding some areas and drying out others. And despite these negative impacts, dam construction is proceeding at a very high rate across the globe. Globally, there are 3,700 new dams proposed. 635 of those are already under construction. And so the impact of a dam on a river can be measured by an attribute called degree of regulation, which is reported as a percent, and it's calculated based on the relationship between storage volume of reservoirs and the total annual river flow volume of a river. So the greater the degree of regulation, the greater the impact of dams on the river. Previous research done by the World Wildlife Fund developed this metric to assess the length of rivers and impacted by existing dams across the world, but they have yet to look at proposed dams. So next slide, please. So building on this previous work from the World Wildlife Fund, we wanted to use open access data sets to look at proposed dams by country and calculate, number one, the total length of rivers on protected lands that are affected by proposed dams, and number two, the total area of protected lands that are affected by proposed dams. So as you can see on this map, we're looking for the overlap between these planned dams, the black dots, and the rivers, which are in blue, and then protected areas, which you don't see on there, but we're looking for spaces where all three of those things overlap. Our final goal is to eventually, later this year or next, make a publication with our partner at the World Wildlife Fund. Next slide. So just a basic overview of our workflow. We first took this free-flowing rivers data set from that our project partner provided and the World Wildlife Fund, and subtracted current degree of regulation from planned degree of regulation, and that helped us find only rivers that have a planned dam on them. And then we only looked at large rivers so that we could optimize the data processing time. Since we were trying to look at the whole world, it made things pretty slow, so we wanted to only look at large rivers. And then we combined two different protected areas data sets to make sure that we got as many, almost all of the protected areas in the world. So we merged Ramsars, which is a UN thing, and then the World Database of Protected Areas. And we subsetted that by continent because, like I said, it was a really large data set. All right, now I'm passing it to Steph.
So we were able to complete analysis of South America, Africa, and Asia. And then we also did Australia, but it turned out there were no dams that are critical to this result in Australia. So just to focus in on what we saw in South America, which is representative of the results we have so far, only a certain number of countries really were having the biggest potential impact. So in the case of South America, Brazil, Argentina, and Colombia have the greatest number of river kilometers that will potentially be impacted. And then Brazil overshadows everything with up to 124 square kilometers of protected lands that will potentially be impacted, followed by Ecuador and Argentina. We also extracted how the degree of regulation would change. And in general, it was only about a change of 10%, but we haven't done a lot of analysis on that part of the data set yet. You can see here the upper graph shows the length of the rivers and the bottom graph shows the areas based on country. So you can kind of see that they track well together. Now, what's not in this data set at this point is topography. There was nothing in our data set that makes any account for topography. And if a landscape isn't in our list of protected areas, it's not represented. So there's probably a lot of protected lands that will potentially be, or excuse me, critical landscapes that will potentially be impacted, but they will not show up in this analysis. Now, this is a pretty general or coarse analysis, but we are already seeing a pattern. And by the way, this is one of our mapped results for South America that shows the degree of regulation increase, and then the the degree of regulation currently, and then the protected areas in green that will potentially be impacted. But this shows that countries that are building dams are the ones that are developing infrastructure because they have water resources and they have the money to do it. Not every country is doing it, but these open access data sets are a powerful tool for us to track these trends. And we really want to then finish our analysis by looking at North America and Europe. We want to include smaller rivers, and we really want to dive deeper into the data attributes and look at the specific differences in increase of DOR, what dam locations are the ones that are critical, and then what type of protected areas are actually being impacted. So with that, I would like to acknowledge Jeff Oberman and Natalie Shaboul at the World Wildlife Fund who helped us on this. And then this shows our major data sets that we used.